Okay, hello and welcome to the late afternoon session of the technology track. I'm Hagit Shatkai, I'm chairing this session. And our last speaker for the day is going to be Emmy Tsang from ELife. And she'll be talking about preparation for a production-ready solution for reproducible articles. Thank you.
All right. Hi, everyone. Thank you very much for coming here for this talk. My name is Emmy. I'm the Innovation Community Manager at ELife. I know it's quite late in the afternoon, so I'm going to try and keep this quite interesting. And I will say, please do interrupt me with questions if you have them in the middle. I'll try my best to answer them as we go, and yeah, keep this interactive. So for those of you who don't know ELife, we are a nonprofit organization started by researchers, run by researchers, and for researchers. So we started in 2011. We're funded by the Howard Hughes Medical Institute, the Wellcome Trust, the Max Planck Institute, and also more recently the Knut and Alice Wallenberg Foundation in Sweden. Most of you, how many of you have heard of ELife? Great. So for those of you who don't know, or most of you who might know us, it's because of our journal. So we run an open access, online-only journal publishing high-quality papers in the life sciences. We are accepting publications in computational and systems biology. If you are interested, please come talk to me at the booth we have upstairs, booth 6. I'll be around until the end of this conference. But you may not know, what you may not know is that we also invest heavily in open source technological development and innovation. We believe that at least some of the problems that in scholarly communications and publishing can be resolved through revolutionizing journals, through making better use of recent advancements in web technologies to create an open publishing infrastructure. So this, we always used to show this because this is a picture of our old office with our mission statement. So ELife's mission is to accelerate discovery by operating an open platform that encourages and promotes responsible research behaviors. And this mission encompasses the work that we do within the ELife Innovation Initiative. So the Innovation Initiative started as sort of a side experiment at ELife, but is increasingly becoming more and more important as the projects grow in scale and gets integrated into the main journal workflows. So the Innovation Initiative's mission is to drive open source innovation for open science through two main methods. The first is to build open source tools, platforms, and technologies to improve the ways that research is discovered, consumed, shared, and evaluated. And the second is through community building. So we support a community of open source innovators to develop these tools. If you have some ideas in this sort of area, please do come talk to me. We do offer support in various forms to make sure that we can realize your ideas. So today I'm going to mainly talk about the Reproducible Document Stack, or the RDS project, a project that the ELife innovation team and our collaborators have been working on for about 2 years now. So I'm going to talk about the motivations behind the project, what we're trying to achieve, and then I'm going to show you what we've done so far and how we're planning to move forward towards a scalable solution for reproducible articles. So how many of you have worked on or published a paper before? That's most of you. So this situation would be familiar to a lot of you. So because you are an organized person, or because you know that someone is going to reuse your code in the future, you put all your code for your analysis in some sort of a markdown format, like R Markdown or Jupyter Notebook. But when you submit your paper, all this is gone. It becomes a flattened PDF, and the code is no longer part of the paper. We've kind of accepted this as status quo. Maybe say, okay, I have a detailed methods section in the paper, maybe a GitHub repository that has all the code. I'm sharing my data on an open repository. I have a data and code availability statement within my paper. My job is done. while it might be enough for other people to reproduce your research, I can take a good guess to say that if you've tried to do this, reproducing results from a paper, it's not easy. So I don't think you need much convincing, but just show you one example here. So this is a beautiful TSNE plot that I found on a paper, and I say, okay, I want to reproduce this particular figure. So what do? I need the data, I need the code. So how do I first find the data? I go, I search for availability there. So luckily, I found a data and software availability statement, which gives me addresses to a GitHub repository, as well as it says that the data is available on the Geo data repository. Great. So I go to the Geo database. I scroll down, and I see, okay, I have 3 files here. Which one do I need for my plot? Then I need to go back to the paper, and I read all the methods, well, half of the method section. About half an hour later, I figured out, okay, I probably need that imputed, normalized, nice data for this TSNE plot. So great, I download this file, and then I need the code to regenerate the graph, and so I go to the GitHub repo that they supplied, and I see this. Great, and so I need to identify which of these 15 files that I need. So, and within each of these files, it's about 300 lines of code that I need to read before I can find the bit of code that will get me that TSNE. So that by this point, I've taken around 2 or 3 hours of my time, and I believe that we can conclude that we can do better than this if the code and the data is just part of the narration of the method. So this is our vision for a computationally reproducible document. It should encapsulate executable and usable code and data within the flow of a manuscript. It should deliver progressive enhancement from static research article for the researchers who might just be skimming and browsing to full code and data interaction for those who actually want to reuse the methods and data. It should be platform, tool, and language agnostic, easy to use and accessible. And finally, if all of these boxes are ticked, it should encourage the reuse of published research. So since 2017, together with our collaborators Stencilla and Substance, ELife committed to developing a stack of open source tools for the authoring and publication of reproducible articles. And earlier this year, in February, we published our first reproducible article as a demonstration of our vision. So here's the address to the demo. You can all access it now or in the future on your phone, on your laptop, anything. I'm going to show it to you now here. So this is a paper published by Dr. Tim Arrington, originally in Reproducibility Project Cancer Biology. On the first glance, it looks like any other ELife paper, but except when you go down to the figures, you can see this button, R-script button on the top left of the figure, and if you click it, you have full access to the code that generated the figure. What's more, you can actually edit this code. I'm going to attempt something very risky here, which is live editing. So this is a bar plot, and I personally have a thing against them. And so I say, okay, can I change that? So I find the code. I say, okay, for those of you who are familiar with R, you can help me out with this. I'm going to change that to a dot plot. So I just comment out the error bars here. Also need a slightly different data frame. And then I can hopefully re-execute that within the browser. Sometimes it doesn't like it because it's not reloaded before. Okay, but here's the moment where you go like the cooking shows where you have a pre-done version. So here it is that I've managed to change this to a dot plot. You have to believe me, and you have to try it for yourself too. You can change colors. People have done all sorts of things on social media and etc. And so, yeah. Yeah, that's a really good question. I mean, is it part so let me ask you one question. If you cannot reproduce this plot using just like this, how do you feel about this science?
I believe if the results are showing what I would get by experiment, I think it's fair. I mean, if you think about it, people used to plot by hand, and plotting by computers is not even a requirement
Yeah.
in science.
Yeah, but it should be trivial, right? Like if I have the same code and the same data, I should get the same plot. The problem is that we're not.
I mean, how you handle so our libraries change a lot. How do you handle the code might be fine, but you might not have the right library to do that particular plot. And that's sort of a generic plot, but it might be a more specialized plot.
Yeah.
And how do you can propose both if you want to propose both.
Yeah, so this is exactly what I was referring to when I say with the same code and data, you cannot reproduce the same plot. And that's because dependencies can change, libraries can change, system parameters can change, but depending on your setup on your computer. And so our method of trying to resolve this problem, which is exactly what's demonstrated here, is that we use a container. And so this is a Docker, on the back end of this is a Docker. I'm going to go into this a bit more further down in the talk. But it means that basically, I'm not a computational biologist. I'm not a computational scientist. My way of understanding this is that I essentially chuck my entire computer onto the internet, and people can download the computer and run the same code on the same computer, which should eliminate most of the issues of reproducibility. So going back to so that's the demo that you can play with. And we do think that by having this sort of code and data reintegrated into the narration of methods, allow the richness of the research to be more fully shared and conveyed, and hopefully it will make it easier for researchers to reuse other people's results. So the demo was released in February, and we got a lot of attention for that. People emailing us asking if we can publish their papers as reproducible documents, and we would love to do that. But for that, we need to build a stack of tools that will allow researchers to easily compose and author these articles with code and data embedded, tools that will host these articles and set up the reproducible execution environments needed to allow these live re-execution, and tools for us and any other interested publishers to accept and publish these reproducible articles at scale. So we want to keep the tools to compose a reproducible article very easy to use. We hope that scientists would not have to learn a lot of new tools to drastically change the way that they write articles in order to make them reproducible. So for that, we're developing with Stencila a tool called Stencila Desktop, which is an open source word processor designed to create interactive, standardized, fully reproducible documents. So I'm just going to give you a taster of that. So this is a demo of Stencila Desktop. As you can see, the visual interface is extremely intuitive and minimalistic. You can cite figures and references without having to worry about the citation formats. Data and code are parts of the Stencila document. You can add these code blocks within the flow of the manuscript, and in these code blocks you can put the code underlying each of the figures. The code cells can reference and interact with data in spreadsheets, which you can access down here in the tabs. The data is also part of, these spreadsheets are part of the document. Stencila supports these code cells in a variety of languages. There are the commonly used ones in science, like Python and R, but also we support a language called Mini, which looks a lot like an Excel formula, and this is intended for researchers who are not coders to use Stencila easily to compose reproducible documents. But beyond that, we want to make sure that, again, people don't have to drastically change the way that they already write articles. We want to make it easy for scientists to create these documents from multiple starting points. So for researchers who are already using some sort of reproducible notebooks like Jupyter or R Markdown, Encoda is a converter that Stencila is building to convert commonly used formats like Markdowns, Google Docs, Word, PDF into what we call DAR, the file format of our reproducible documents. So most of you might be familiar with something called PanDoc, which is an open source converter that allows you to convert between many different common markup formats. One of the problems with PanDoc is that when you convert from notebooks to flat file formats like Microsoft Word documents, it flattens code chunks into plain text and doesn't really preserve their identity. Stenciller came up with a very smart way around this by using something called the reproducible PNG, or RPNG. So when an encoder converts a notebook document into a Word document, it saves the generated output from a code chunk into an RPNG. So let's say this is the figure or the output that you get after the conversion. And you say, okay, have I lost the code? Actually, the Stenciller node is encoded in the text chunk of the RPNG. So if you back convert now, that's this Word document, the code chunk's identity is preserved and hence can be re-executed. And this is very useful in a scenario where, for example, you work with a Jupyter notebook, but your collaborators or your supervisor doesn't. And so you have to send it to them in Microsoft Word, and then they come back to you, and you still have your notebook formats and code blocks preserved. So all of this is work in progress, although version 1 should be released quite soon and will be available as part of the command line version of Stenciller. The most important feature of encoder for reproducible articles is the DAR compatibility. So DAR specifies a virtual file format which holds multiple digital documents. A DAR consists of a manifest file, which is an XML file that describes the content of the DAR. There are two different types of content. The first is documents, which are typically stored in XML in a particular standard called JATS. This is a standard that's used commonly in publishers. And the second type of content in this DAR are assets, so regular files that can be used by the documents, like images or CSV spreadsheets. Again, we envision DAR to be the standard file format for reproducible documents. The idea is that DAR will be a target for conversion from R Markdown, Jupyter Notebooks, Docs, Google Docs for publishing. DAR is also directly authored on Stenciller Desktop that I just showed you, and you can convert DAR to all of those other formats, again, for collaboration with colleagues who might not be familiar with this file format. DAR is an open format that can be used by everyone, and Substance, who is the kind of creator of this format, is currently extending it to support our Markdown inline codes, giving DAR greater interoperability with mainstream tools for computational reproducibility. But bundling manuscript code and data together into a DAR file doesn't really give you the ability to regenerate or modify the figures on the fly. We also need the compute environments with the correct software and packages installed. To build reproducible computing environments, we can make use of Docker images. So a Docker image is an executable package that includes everything that's needed to run an application: the code, the runtime, libraries, environmental variables, configuration files. Whenever you run an image, you launch a container, which is a runtime instance of the image, and provides you with a computing environment as described by the image. Docker images are a great solution for providing reproducible computing environments, as it means that as long as the configuration files don't change, the image and hence the environments won't. However, they're not really easy to build, even for a computational scientist, and image files are often very big, and hence the containers take forever to launch. As a publisher, we really need reliant and performant containers to be able to run the live code elements in a reproducible article. That's why Stenciller Hub is built to provide such execution environments. And Stenciller is developing additional functionalities for the hub specifically designed for the publisher's use case. The aim is to build a robust, scalable software and personnel infrastructure for the provision of execution services in support of the RDS, as well as to enhance the overall user experience. So Stenciller is working on optimizing various parts of the technology to achieve this. An example of this is called Doctor, through which they hope to explore solutions to optimize the size of Docker images to the bare minimum required for a reproducible document. The ultimate aim is to enhance the efficiency and scalability of reproducible computation. Doctor achieved this by performing static code analysis of the DAR to determine the package requirements so that users don't have to manually compile and maintain a list of package dependencies, which is often one of the most difficult parts when it comes to building a Docker image. Docker uses package databases to determine existing package system dependencies and generate linked metadata. It also makes use of existing package managers to make installation and reinstallation of packages faster, which can be very helpful in projects where the dependencies are always changed. Further in the future in our roadmap, Stencila is also working on something called Nixter, a tool similar in concept to Docker but built for Nix images, which is another way to provide reproducible execution environments. These tools are all modular so that they can be adopted by other tool stacks who are interested in producing more specialized and efficient images. It also future-proofs the technology stack, providing alternative solutions even if in the case, say, where Docker disappears. So once the DAR has been created, it's uploaded to Stencila Hub. Next, we have to think about how to make it available to readers. Here we adopt a strategy called progressive enhancement to scale the output to the level of user engagement. So through sort of user research and testing, we identify 3 main types of users to a paper. You have your casual readers who are just kind of searching and browsing, discovering the paper, deciding whether or not they still want to read it further. You have partial readers who are skimming through the paper and deciding whether they want to interrogate like with the figures a bit more. And finally, you have the full deep readers who are interested in exploring the related resources, interacting with the data, reusing the code. So for the casual readers, the entire article that I just showed you, including the reproducible figures, are all pre-rendered. So it just means that it's faster and doesn't take forever to launch that whole container just because you want to skim through the paper. When the user edits the code, the document connects with the container that's hosted on Stencila Hub. So here are some, I'm showing some of the wireframes to illustrate some of our working ideas. So say if you're just skimming through the paper, you don't really want to spend more than like 2 minutes on deciding whether or not you want to read it further. It doesn't make sense for you to see all the code. So our idea is that when you first browse a paper, you see this pre-rendered version of a figure. And then if you actually go and click on the figure, you see this pop up. And you have the caption on the side. You have more information on each of the data points on hover. You could have the possibility to have drop-down menus or sliders to play around with some of the parameters. There's no coding skills required at this point. But if you really want to go fully into exploring the code and data, you can click some of the buttons. You can click some of the buttons here. So if you click this one, it will give you the data, and if you click this one, the code will show up. So these are just some of the ideas that we're thinking of. We're open to all sorts of feedback. Technically, there are 2 ways that we can achieve this progressive enhancement strategy. So the first is that remembering that at the moment the article exists in the form of a DAR hosted on Stencila Hub. So the first way is for the article to be converted into HTML. The HTML is served from Stencila Hub. It is progressively enhanced using JavaScript to make the reproducible elements live by connecting to the execution environment built for the article, which is also hosted on the Hub. And the second way is to render the DAR by JavaScript within the browser using an interface that is hosted by ELife or other publishers, which connects to the execution environment built for the articles and hosted on the Hub. And this was the setup that we used for the demo. We're also looking into tools to allow exporting of the reproducible articles into PDFs for offline access and legacy systems, and further in the future, integrating DAR submission and reviewing into the journal submission infrastructure. So we strive to develop the RDS in accordance with these 3 core principles. We commit to working in the open. We are not trying to win any sort of tools race. We aim to maximize our reuse of existing open technologies wherever applicable. All of our tools are in turn created openly. The code base is all on GitHub. We aim to communicate and update the community on our development progress and milestones to actively collect feedback and to foster collaboration. We also understand that the research and tech ecosystem evolve very quickly, and hence it is important that the tools are interoperable and future-proof so that the infrastructure can be efficiently maintained, and it means that users don't have to constantly switch or learn new tools. And finally, by building in the open and keeping our tools modular, we hope that other innovators in the community can build on top of our technological innovations. So I'm sure many of you understand the problems that we're trying to tackle are difficult, but I hope I've provided an overview of the concrete roadmap towards a scalable solution for authoring and publishing reproducible articles. To address more complex use case step by step, we need to learn about them. So we'd really appreciate your feedback and insight at this point. And the most efficient way for you to do this is actually to ignore this link, but to come to my session tomorrow. So I'm running a Birds of a Feather session at BOSC tomorrow, same time as this talk. We haven't got the location yet, but do check out Twitter, which should tell you sometime tomorrow where it's gonna be. But basically, I'm trying to run an exercise to understand where the reproducibility pain points are. So if you're trying to reproduce results like Alice here, what is the biggest obstacle? What is the most time consuming? What kind of troubles do you run into? And we need to understand all of this and the complexity of the problem, and so that we can tailor and build our solutions towards tackling those problems. Ultimately, the RDS is a project for researchers, and so we really want to make sure that your inputs matter. So please do come and tell me about all your problems, and we'll try and record them in a sensible way so that we can actually feed back to the developers and make sure that they get addressed at some point during our development process. The other thing that you can do is to sign up to this bi-monthly email updates. It will keep you updated on what we're doing with Sensilla and Substance, our outreach opportunities and ways that you can contribute, for example, beta testing or any sort of tooling, open tooling sprints opportunities. So that's all from me for now, and I'm happy to take any and all questions. Thank you very much for listening.
So in your TISNI example, if it was on your, if it was in ELife as a reproducible document, would the document perform the TISNI and then plot, or would it only plot the post-TISNI data? So how much analysis is done in the code?
Yeah, that's a really good question. I'm just going to snap back to the mic. That's a really good question. So the TISNI plot would be pre-rendered for anyone who's not playing with the code. And if that code block contains the running of the TISNI, then the whole TISNI will be rerun. We do understand that at some point this doesn't make sense anymore, because if your paper includes some sort of a 7-day deep learning model, then it would completely destroy the system. So that's why we need this conversation. We need to figure out what we can do. At the moment, the demo is a very simple, small, neat CSV sheet, so it runs perfectly. That's why it's a demo. We haven't got the perfect solution yet. We do have a blog post exploring exactly this problem on ELife Labs. That's elifesci.org/labs. We don't have an answer. Again, it comes a bit down to, yeah, sorry, I'm giving a really long answer to this, but feel free to stop me at some point. So it comes down to what the point of reproducing things are. Are we trying to make sure that things are reproducible, or do we actually want to re-execute it? And that's two different questions, and those yield two different answers. And so one way to tackle that problem is to divide the code blocks smaller so that you'll have the results from, so let's say your TSNE, actual TSNE algorithm or line of code is in one code block separated from the matrix that you get out of the two column matrix that you get out of the TSNE, then that goes into another code block. So if you just want to recolor your TSNE, you don't have to rerun the whole TSNE, which makes sense. But then that's kind of up to the author, right? And so then, yeah, this leads to a whole conversation about, how big should the code blocks be, but yeah.
Yeah.
Sorry, long answer.
So, yeah, building on that, pretty much the same question. He's talking about computational demands, but the data demands, if I'm doing a transcriptomic experiment, are you going to host all of that data within your RPNGs, or how are you going to kind of address those data hosting, data provenance, ETL, all that other stuff that also goes into the experiment that is not necessarily going to be in the R code itself?
Yeah, so at the moment, I would say, like, in the foreseeable future, we're tackling cases that usually goes into, like, the amount of data that usually goes into the superficial layer of a paper, if you see what I mean, like tabular formats in CSV forms, so small sets of data, not like, entire FASTQ files or something like this. But we are open to exploring, we are actually exploring ways so that we can have hosting and these execution environments so that we can actually serve up bigger sets of data. Again, it's not perfect. It's very much in progress. We're talking to different people. If you have a solution, please come and tell me. Yeah.
Hi. So I suppose, first off, thanks for the talk. That was actually really, really interesting.
Thanks.
It's actually kind of nice to see publishers taking any sort of vague interest in this.
Thank you.
So what I wanted to ask is, so obviously there are several tools that are already being integrated into this sort of platform, and more generally that somebody else might also integrate into a similar platform. But there's a whole bunch of other tools out there that are really, really useful for either locking up something in a container or managing dependencies and ensuring someone doesn't have to deal with that, or making something reproducible. For example, some people can't use Docker because their sysadmin is paranoid and won't install it for them. So is there any intention or any plan to extend this sort of platform to integrate with other tools, such as, for example, hosting stuff on my binder, or using like virtual environments or pipenv or conda as other alternatives that people can then use to, clone the project off GitHub, Bitbucket, whatever, reproduce it all, and compare it to something that's being hosted? So say, playing into the other question, if something's a bit too intensive to run live on some free server, but giving someone the option to just clone the entire paper project and have their choice of, I want to run it in Docker, or I want to run it in pipenv. Is that something anyone's looking into?
Short answer, yes. So, yeah, so the idea is like, we don't expect people, at least not at this point, to run, deep learning models on a browser. We expect people to download it and run it locally, because that's realistically what we can deal with. The demo, by the way, is built on Binder. So we don't, this is why we keep everything open. It's because we want people to use alternatives, and modular, because so the bottom line is, as long as you can export into a DAR, we can publish it. So if Binder can be exported into a DAR, then it could be fed into the ELife publication pipeline, if you see what I mean. So yeah, we welcome any tool developers to come talk to us and see how we can make that more clear, or make everything more interoperable, and make sure that everything kind of fits better together, whether it's data hosting or manuscript writing or citations, anything. So that's why we are here to talk about this. Thank you.
I think, so I'm just thinking about a paper that I'm trying to put together, which involves maybe 6 months of elapsed computing time. And so I think at some point, a reviewer, I would like to make that more reproducible. I can try to put the pieces into Docker containers. Maybe it involves a benchmarking of, say, 10 software. So I might want to put each benchmark into a Docker. No reviewer is going to be able to actually run those either, right? So at some point, you're going to have to push the responsibility back onto the, for that kind of case, you're going to have to push the responsibility back onto the author, right? And the reviewer is going to have to look at the Docker container and run a piece of the code or run a small piece and try to decide if it's really working.
Yeah.
I mean, there's going to have to be some limit. Just like in a lab, you can't have the reviewer do all the 3 years of experiments to review a paper either, right?
Yeah, no, I think that's really true. I think we haven't settled on kind of what we want because it's such at the beginning of a huge experiment. And so we haven't settled on any sort of idea. And I do think that we evolve together with the field. Like you have, I don't know if you guys know Gigantum, who we wrote the blog post with. I mean, in the end, it's about, you know, how, again, this question of what are you trying to achieve? Do you just want to, like, do reviewers just want to know that this is reproducible? Or do they actually want to reproduce part of it? And there's a case for both of these scenarios. And in the end, I personally feel that we're moving towards an age where things happen a lot faster. And so people are publishing faster, and people are publishing either in smaller pieces or in like rawer forms or other forms of output. And that goes into the whole conversation about, you know, the way I see it is sort of the newspaper publishing to live streaming progression, or the Microsoft Word to Google Doc translation, where you have people just putting out stuff line by line instead of having this whole deployment thing. So this is a whole conversation. I'm sorry, it's getting philosophical, but it does tie in with all of this, and I think this is a very good platform and point to have this sort of conversations, to understand what we actually want and make sure that we build tools that will facilitate interaction and collaboration on all of these levels.
Thank you. Very nice talk. Actually, I want to follow on the very first question. Is like, is the code running the actual data or just plot the graph? Actually, that make a lot of difference, because from my point of view, if you just plot the graph, actually you can just doing the image analysis to try and understand the graph in the PDF. Actually, you can reproduce the graph itself automatically. So I prefer to running the whole data, but that could be like take very long, as you said. If it's running a deep learning model, that could take days and a lot of source of data. So like, yeah, I just want to involve and like add my opinion on that question. Mm-hmm. And actually, I'm interested in like you said you will like transfer or converting the PDF or Word on Google Docs to the XM file, and I really want to know the quality after the conversation, and is that like good enough, and what's the challenge with it? Okay, thank you.
Thanks for that. I mean, that's kind of two separate things, right? So before I forget, answer the question on the conversion, please go on to github.com/Stencila. They encode the code base is entirely there. You can go and try it. I think they have a beta version or an alpha version at least, that you can try out and see and assess the quality yourself. And if you have the skills, please do. They are a small team. Please do help them out and contribute and give them feedback on how they're performing. And then I lost the second question. The plot. So again, for me, it comes back down to being able to cater for all of these different use cases. So if you just want to, like a lot of people just want to change the colors or just want to replot in a different format. A lot of people like you also want to, go from scratch and analyze the data from the beginning and then all the way to the end. And so we need to make sure that all of these would work. The browser interface is the interface that you would use to replot the graphs, and there is definitely going to be a functionality where you can download the entire DAR file or the entire container so that you can actually run it locally, and those would facilitate better, at least at the moment, for this sort of beginning to end type analysis. Does that answer the question?
But I mean, just to plot the graphs, actually you can read the histogram or the plots in the graph, and if you read the data and the axis label, actually you can reproduce it automatically, right? And several groups is like working on like graph analysis, trying to read the data within the graph or table, similar stuff, I guess.
So So you mean like there's a software that can read a graph and regenerate the...
If you read the graph, actually, you can try to produce the graph automatically.
Yeah, but you still need the data frame or the matrix that produced the graph, right?
Yes, you can read the data within the graph. You can read.
So we can continue this after maybe, yeah.
Yes, I think, so notwithstanding, some of the practical issues with large data sets and long computational times, I think the sort of prescriptive attitude here is important, that the reviewer should be able to at least look at the code, right? Because many times now, even with these very high-profile papers like the TCGA, Cancer Genome Atlas papers, it's really very hard to tell what people actually did. And in fact, it's not possible unless the author is willing to then engage in a dialogue with you. So I think journals probably can do more to ensure that actually the code is available so that you can actually tell without having to hope that the postdoc will answer your email that what was done, right? So even though there may be issues, I think it's also the cultural embedding is very important here.
Yeah, no, I definitely 100% agree. I think like by offering this sort of tools and making sure that it's available, we do try to change the culture. So it like having a paper like this for me changes the way that you think about the way that research is done. So much of the method writing up right now is post-hoc, and that's not the way that it was supposed to be done. You're supposed to have figured out the methods before you arrive at the results. So that's one part of it. And but you're absolutely right. My struggle with this is that if you just, as a reviewer, if you look at 300 lines of code, can you envision in your head if this is all going right?
Not totally, but you can see if there's serious issues for one. So
Mm-hmm.
you can see things,
Yeah,
right? And at least was it a one-sided test or a two-sided test? Right?
yeah. And these nuances are not captured currently in the text description of the methods.
So it's a form of quality control.
Yeah,
Right?
yeah, gotcha.
And if the code is so awful that you can't possibly understand it, that could be a comment also.
Yeah, yeah. So at the moment, I'm not sure if can you see the code that are hosted on GitHub, for example, if they are provided with the paper?
Yeah.
Great. So that would hopefully solve part of the problem, right? It's just that if it's integrated as part of the journal kind of peer review system, then it will make it better. Yeah, so that's a good intermediate. I would say that's definitely a good intermediate that we should consider. And, well, it's a byproduct almost of making people submit DARs to us, because you can definitely then have access to the code. Yeah.
So I have a question about the Stencila desktop functionality, specifically with regards to figure placement.
Mm-hmm.
So if I'm writing a paper, a lot of times I might have 15 figures, so maybe 6 of those will go in the main manuscript, and then the other 9 would go in the supplementary material. But I don't always know ahead of time where I want to put the figures, whether I want to put them in the main manuscript or in the supplementary material, or even in the main manuscript I might want to change up the order a little bit.
Mm-hmm.
So just wondering if there's any functionality currently, or maybe in the future, or maybe this is just a hope for a feature that could be implemented later, that you could dynamically move around your figures and be able to have it automatically rename them and be able to refer to them in the right order automatically, something like that.
Yeah, I think this is at the moment definitely a feature request.
Mm-hmm.
So I'm not I do think that is doable. Top of my head, the solution right now is to create 2 different things and then you just kind of copy and paste, which is honestly not the smartest solution ever. So maybe it's worthwhile to have an extra function where you can just say, okay, this is a supplementary, and you move everything there while not breaking your sort of container and pipelines. So within the DAR, you can definitely have multiple documents, which means you can have multiple manuscripts going, referring to the same container, if that helps. But go and on GitHub and try and talk to those guys. I mean, they've got a lot on their plates at the moment, so please be patient. But they if you can contribute, that would be even better. They're always looking for help. So
So is there a paper, does ELife come out in paper? Does it come out in paper?
No, it's print. Sorry, it's online only, open access. Yes.
So, I mean, maybe it isn't really so necessary. I mean, a lot of it's driven by the printing costs, right? So maybe it's not necessary. Do you have that structure in mind?
You mean
Main text and supplementary information with supplementary data.
We do have supplementary materials. You can submit those. But I understand your point, but I also understand the fact that sometimes when you have the main flow of, like, it's almost like a highlight of the entire research project, right? And so do we need to keep that? Is there a need for it? I personally think there is, but I'm open to disagreements. Like, if you just have like a long narration of like 100 figures, would that be a problem at some point? I mean, it's all, yeah, the entire ELife journal was open source, if you're wondering. It's all in one GitHub repo. So you can go and explore that. And I think editorial will have more to say about the structure of the paper. But I mean, at the moment, we're not really changing that. When the technology becomes more mature, we're definitely open to a conversation on kind of how long a paper should be and how many figures it should have.
Yes, thank you very much for the interesting talk and for doing this. Are you aware of Distill? That's some kind of journal that's also doing digital science.
Yeah.
So they are doing some interesting thing with reproducible reviews also. So you can see what the paper was published as and how it was first given to the journal and what the reviewer requested to change and stuff. And I guess that's also something that ties into reproducible science, that you know what was changed, and do you consider this in some way?
Yeah, this is the other elephant in the room that we're trying to solve, other than the whole big data problem, version control. So we haven't got a solution yet. We would love for someone to tell us how to do it. Like, the ideal would be like, if you, because at the moment, if you go to that demo, you can change the graphs, but you can't save it. So the only way you can preserve that change is for you to take a screenshot, which completely destroys the point of the whole thing. So we are looking into solutions. Again, like, our focus at the moment is just to be able to accept and publish 10 of these articles by the end of the year. Already a big enough challenge. But we are, we're aware that it's very important that we do collect all of these different, like, parts that we need to improve on, and that will be the next part of the roadmap. And we also need to prioritize it, so that's also another conversation. But yes.
Have you worked with or considered to work with organizations that, for legal or regulatory reasons, have to make sure that their reports are reproducible? I'm just wondering whether this may be perhaps an easier step for you to get into this large area of making things reproducible, while also being of benefit for those organizations that do have to have reproducible reports.
That's a very interesting thought. We haven't. This is the short answer, but I'd love to, please tell me if you know of any and if there are any ways, because I would be interested in understanding how they verify reproducibility. Like, what sort of requirements are there, and what do they mean when they say there's a legal requirement that this should be reproducible?
Yeah, perhaps we can do this offline. I can tell you a bit more about it.
Yeah, definitely.
I'm working for a pharmaceutical company, and for us, this is a real issue.
Ah, fantastic. Yeah, I'd love to learn more. Thank you. Thank you very much, everyone. Thanks.